Alright, so the last question of paper 1, May 2023, time zone 1, says two lines L1 and L2. L1, L2 intersect at point P. Point A is 2t 8 3, where t is greater than 0, lies on L2. This is shown in the following diagram. The acute angle between the two lines is pi over 3, and the direction vector of L1 is 110. I've written that here. And PA is 2t0 3 plus 3. Now let me quickly check something. So yeah, cosine of, all right. So we can use, so for part A, it's asking us to show that 4t is equal to radical t. Okay, so we can solve this for part A of A. I'll solve this here. We can use the formula. Cosine of theta is equal to the magnitude, wait, no, the dot product of PA and D1, as well as over the magnitude of PA times the magnitude of D1. So why PA and why D1? Well, we know the angle between L2 and L1 is pi over 3. We have the direction vector of L1, and we also have PA, and PA lies on L2, so it's somehow the direction vector of L2 as well. So we can use this to show that for t. All right, so cosine of pi over 3 times the magnitude of PA, which is radical 4t squared plus let's see, 9 plus 6t plus t squared, and then the dot product of PA and D1. So the dot product is going to be 2t plus, yeah, 2t. Right, so cosine of pi over 3 is 1 over 2. Right, so I'll just write this here. So 1 over 2, and then multiply both sides by 2. You'll be left with 4t is equal to radical 4t squared plus 9 plus it appears that I've made a slight mistake. Where is my mistake? 4t squared. This is 0, and then 3 plus t squared, which is 9 plus 6t plus t squared. I don't understand where the mistake is. Well, I think it's connected. 5t squared is going to be 5t squared plus 9 plus 6t plus 9. 6t plus 9. So magnitude of D1. Oh wait, forgot the magnitude of D1. Magnitude of D1 is 1 plus 1, so radical 2. So that's why this is going to be times radical 2. I forgot to times radical 2 here. Where should I times radical 2 as well? So this is 10t squared plus 12t plus 18. Alright, so you get the idea, you get the gist of it. Now we're asked to find the value of t. So we can square both sides. 4t squared is equal to 10t squared plus 12t plus 18. We'll be left with 6t squared plus 12t plus 18 equal to 0. I'll factor out the 6, so t squared plus 2t plus 3 equal to 0t. Let's see, t. Why is this happening? I don't know. T squared 2t squared. So this is going to go to the 4. Oh, this is 16. This is the second time I'm making this mistake. So negative 6t squared. Yeah, I'm gonna write this as minus 12t minus 18. So minus 2t and then minus 3. So minus 3 and then t plus 1 equal to 0. So t is equal to 3. As t is greater than 0. Alright. Now part C, find or hence or otherwise find the shortest distance from A to L1. Shortest distance. So you can use trigonometry here. So I'll go ahead and just for the sake of visualization, I'll put a dashed line there. Hopefully you can see it. And you want to go ahead and find this distance. I'm gonna label it B. Right. So we have the point P to A. Right. So PA, you can find its magnitude. We already found it. Magnitude of PA, we have T now. So 2 times, this is going to be 6, 6, 0, 3 plus 3, 6, 6, 0, 6, 0, 6. So its magnitude is going to be a radical 72, right? Let me check with my, yeah, radical 72, I'm correct. Radical 72. So this right here is radical 72. And we want to find the magnitude of the shortest distance. So you can use sine pi over 3. That'll give you d over magnitude of PA. And so d will be radical 72 times radical 3 over 2. That is radical 216 over 2 meters. Is that meters? I'm not sure. It's not right meters. So this is the shortest distance. Now, in part D, we're told a plane pi contains L1 and L2. Find a normal vector to pi. So this is fairly easy. Let me erase these. So we have t. I'll just add t is equal to 3. And the shortest distance is radical 216 over 2. So this is L1. Just give me a second. For some reason, the ink of this marker just. Alright. So there we have. Oh, we want to find. Okay. So we have the vectors of L1 and L2. You can simply use cross product to find the normal vector because we know that L1 and L2 are in the plane, so their normal is going to be the same. So L1 plus L2 equal to, so what's L1? 1, 1, 0, and then 6, 0, 6. So L1 plus L2 will be I 6 minus J 6 plus K, please don't tell me negative 6. 6I minus 6J minus 6K. So the normal vector will therefore be 1, negative 1, negative 1. That's normal to the plane. Now the base of a right cone, oh this is lovely, lies in pi, the base of a right centered at A. Right, so the cone is centered at A such that L1 is tangent to its base. Right, so tangent to its base, I'm gonna assume this is the base right here. And then the volume of the cone, we're given the volume. So volume of the cone is 90 pi radical 3, 90 pi radical 3 cubic units. Find the two possible positions of the vertex of the cone. So the vertex is the top part, right? So imagine this is your cone. We have at point A, this is A, and then we don't know its height. So let's first find its height, but we know its radius, it's tangent to L1. So we're gonna assume the radius of the cone is equal to D, which is, I'm gonna simplify this as 3 radical 6. Right, so the volume of the cone is given by the equation 1 over 3 pi r squared h. So let's find the height, 90 pi radical 3, 1 over 3 pi of 9 times 6, which is 54 h. Let's write this as 9 times 6 for the sake of it. And so it's going to be what? H is going to be, the pi's cancel out. You'll be left with 2, 1, 90 radical 3 divided by 18. So I'm going to say 90 divided by 18. I have no idea, honestly. Part E. 5 radical 3. I was going to guess it actually. 5 radical 3. 5 radical 3 units. Alright, so that's the height. Okay, now the vertex. The vertex, let's say the vertex is OB. Right. And so OB is equal to given by OA plus, and then we have, so this, right, so imagine it like this. So this, it's centered at A, right? So A till up here, and so we have to plus it with, so the direction vector is going to be the same as the normal vector. So mu 1, negative 1, negative 1. So OA is 2t, which is what? 6, 8, 2, 6, 8, 3. All right. Now we're trying to find so if we say so if we have this, right, this is its height as well, so we can say the magnitude is equal to the height. So yeah, so mu times the magnitude of n is equal to the height. Right. Yeah. So we have this. It's going up. We don't care about the point because it just gives us the position, but the direction vector is important. So the magnitude of the normal times mu. So mu is going to be let's see, so mu squared plus mu squared plus mu squared. So 3 mu squared, right? Yeah. Radical is equal to h. So radical 3 mu squared, radical 3 mu squared is equal to 5 radical 3. And so mu will come out, so it's mu radical 3, 5 radical 3. Radical 3's will be cancelled out, and mu will be equal to 5. And this is 5 plus or minus 5. It's radical. So OV can either be 6, 8, 3, 6 minus 5, 8 plus 5, 3 plus 5, which is 1, 13, and 8. 1, 13, and 8 is correct. 1, 13, and 8. Or it can be 6 plus 5, 6 plus 5, 8, 6 plus 5, 8 minus 1. So yeah, so 6 minus 5, or 6, 8 minus 5, and 3 minus 5, which is 1, 11, 3, and negative 2. Yeah. So in the first one, our assumption is that mu is what, negative 5, and then the second one is mu is 5. Right, so let's review. So imagine we have the cone, the vertex at point A, right? And we know this from here, the direction vector is equal to the normal to the plane, so 1, negative, negative 1. This is the magnitude of this times mu is equal to the height of the cone. Yeah. So it's centered at A, and that's why we put the coordinates of A. Hope that helps.